Hello Gators, this is 4-1 congruence. I can use a composition of rigid motions to show that two objects are congruent. Let's talk about congruence. Two figures are congruent if there is a rigid motion that maps one figure to the other. So a rigid motion that is sometimes called a congruence transformation because it maps a figure to a congruent figure. In this example, the two triangles are congruent because you can do a reflection over the line M and the angles and the sides all match. Let's take a look at using properties of rigid motions to explain why these two triangles are congruent. So we can start with any one of these triangles. I'm going to start with this triangle and I am going to move it so that it maps onto X, Y, Z. So I remember that I want A to map on to X. So A is up here at the top, X is at the bottom. So I think I'm going to go through a reflection across the X axis. So 1 unit up, 1 unit down, that'll be C prime, up, down, B prime, and then A will be all the way over here, A prime. So now the triangle looks like this. So we have done a reflection over the x-axis. And remember that rule is xy maps to x and then opposite of y. Okay, now we want to map this A prime onto X, and it looks like I can do it by mapping, by reflecting across the y-axis. So C will map over to here, B will map over here, A will map over here, and now I have that red triangle mapping onto the triangle I want. And what I've just done is a reflection over the y-axis. And so I took all the points on the red triangle and I mapped them onto this. Okay, and so now that I have seen these rigid motions take place, now I know the triangles are congruent. Let's take a look at this problem again. We could have really done this problem in one rigid motion, and that rigid motion is a rotation of 180 degrees about the origin, and that will take all my points x, y, and map them onto opposite of x, opposite of y. Let's go ahead and make sure. I'm going to take point A, which is 1, 4, and I'm going to use the rule, and the rule will be -1, -4, and remember that A is supposed to map onto x, and let's see if that's where x is located. And sure enough, x is located at -1, -4. So I know that this rigid motion does work. So let's complete the paragraph proof showing why two triangles are congruent. These two triangles are congruent because there is a composition. Composition is more than one. Composition of rigid motions that will map each figure to the other. Congruent figures have the same size and shape because rigid motion does not change angle measure or side measure. Let's take a look at these two triangles. They are congruent. And when the triangles are congruent, the order is very important because it tells us exactly that angle P is congruent to angle S, angle Q is congruent to angle T, angle R is congruent to angle U, segment PQ is congruent to segment ST. I'm using the first two letters, goes with the first two letters. The second two letters, QR, is congruent to the second two letters, TU. And then the first and the last letter, PR, will be congruent to SU. And so what we're saying is this angle, angle P, will be congruent to angle S, and angle Q will be congruent to angle T, and angle R will be congruent to angle U. PQ, that's this, will be congruent to ST. QR, right here, will be congruent to TU. And PR, 3, 2, 3, will be congruent to SU. Now let's describe a sequence of rigid motions that will map the triangle onto the other. So I'm going to start with the PQR. You can really start with the other one if you want, but I'm just starting with PQR. Now I know that Q has to map to T. Now you see how Q is up here at the top and Q is here at the bottom. So in order to make Q go to the bottom, it might not be a bad idea to do a reflection over the x-axis. So to do a reflection, remember this is the rule. I'll be going down to, this will be now P prime, and then Q prime will be right here, and then R prime will be right here, R prime, and it's going to look something like this. Now you can see they look like they have the same direction. It looks like I'm getting a 1, 2, 3, 4, down 1, 1, 2, 3, 4, down 1. Looks like here I have 1, 2, 3 over 1, 1, 2, 3 over 1. So that looks perfect. All I have to do is a translation. And the translation is I'm just going to move this point P prime 1, 2, 3, 4, 5 units to the right. 5 units to the right and not up or down. So that means the rule is going to be x plus 5, comma, y. So this will be moving over 5, map here, move over 5 here, move over 5 here, and you can see that it will indeed map to this. So that's what congruence is. It's a sequence of rigid motions that map one triangle onto another. Select all the statements given that are true about triangle PQR congruent to triangle STU. Stop the screencast and see what you can do. And here are the answers. We can see that we don't, PQ, the first two letters goes with ST, and so that's why this doesn't make sense. Angle R is the third letter, and it goes with the third letter here, so that should have been counted as true. I should have counted that one as true. Angle P goes with angle S, not angle U, so that's not right. And QR, the last two letters, goes with TU, and those aren't correct either. And I think that's the correct answers.